Hi everybody. Today we're going to we're actually going to skip chapter 2 and we're going to move to chapter 3. We're going to do a little mini unit on three-dimensional geometry. So we're going to start off today with 3.1, which is all about cylinders. Let's go ahead and get started. Go ahead and title your notes 3.1 Cylinders. The date today is 4/21. So we've all seen a cylinder. It looks something like this. Could draw a little one up here if you want to. Something like that. Kind of a circular tube. So before we start really talking about cylinders, I want to talk for a minute about circles. We haven't gotten into circles too much, and I actually want you to think, how would you define a circle? Without looking anything up, just pause the video right here and think about it for a moment. How would you define a circle? The technical definition of a circle is a two-dimensional figure. That means like a flat figure where every point is equidistant or equally distant from the center. So if we can picture a circle, something like this, and we have the center, every point on this circle is the same distance away from the center. No matter which point we pick, it's going to be equidistant from the center. So let's talk a little bit more about circles. How do I find the area of a circle? So area of a circle, we're going to need some terminology here for a circle first. So if I have a circle, this distance from the center to any point on the circle is called the radius. We like to call that r. So r equals radius. 2 times r is the diameter. So this distance here is what we call d. d equals diameter. And the circumference of a circle is basically the perimeter of the circle. So we call that capital C, circumference. Circumference. So the way that we find the area of a circle is we take pi, this number, which you can just approximate as 3.14 if you'd like to. Pi times the radius squared, and that's just the radius squared. We're not squaring pi. So this is pi times r squared. This is going to come in handy when we talk about cylinders. So let's move on from circles. Let's draw a cylinder here. So the trick to drawing cylinders, by the way, is draw kind of like an oval, kind of a squat circle. And then you want to draw 2 lines coming down and a kind of curved line at the bottom there. And there's your cylinder. And you can draw a little dotted curved line here to show what's missing or what we can't see. So we have 2 circles, basically top and bottom, and kind of this long space in between. So we don't really talk about the area of a cylinder. We might talk about the surface area or the kind of amount. If you were to wrap wrapping paper around a cylinder, we could talk about the area that would cover. But more often we talk about the volume of 3D shapes. The volume is basically the amount of space contained in an object. So we can write that down. Amount of space contained in an object. So we might talk about the volume of a cylinder if we'd want to fill it with, say, water or sand. We'd want to know how much water or sand that cylinder could contain. So the volume of a cylinder is found by taking pi r squared, where r is the radius of either one of these bases here. So either that one or this one, they should be the same. So that's just the area of the circle, and then we're going to multiply that by h, the height of the cylinder. So basically all you need are two numbers, r and h, to be able to find the volume of the cylinder. Let's do an example together. Let's say we have this cylinder with a radius of 3 inches and a height of 10 inches, and I want to find the volume. Whenever I try to find the volume, I always put the formula up here first. So V equals pi r squared h, pi r squared h. So this is going to be pi times 3 squared times 10. And I'm going to do my exponents first. So it's pi times 9 times 10. And this is going to give me, basically, if I wanted to keep it in terms of pi, or if I wanted to have pi in my answer, I would just say that this is 90 pi. That's my volume. What units am I using? Well, we're using inches, and with volume, we always use cubic inches. So if you can imagine, if I have a little inch, and I have a cube that's an inch on every single side, this is kind of a unit of space. We're no longer just talking about area, where we might have a square inch. We want something that can be taken up like inside of this cylinder. So I'm talking 90 pi cubic inches. We say this as cubic inches. Or we could leave this in terms of, or without pi, we could call this 282.7 cubic inches. Either way is fine. I will accept either answer. Let's do another example. Let's say I have this really high cylinder. It's 25 feet tall, but I don't know what the radius is. And I'm told that the volume equals 314.2 cubic feet. Let's see if we can find r, the radius. So I'm going to write my trusty formula here. V equals pi r squared h, and I'm going to fill in what I know. So V is 314.2 pi times r squared, I don't know what r is, and then times 25. Okay. So next, I'm going to try to get r by itself, but I'm going to have to get rid of these numbers here first. So I'm just going to divide by 25 pi on both sides. Divide by 25 pi, and make sure when you plug this into your calculator, if you plug this in, little side note here, I'm going to do it at the bottom. If you want to do 314.2 divided by 25 pi, and you plug that into your calculator as 314.2 divided by 25 times pi, your calculator is going to want to do this first and then multiply the answer by pi. You don't want that. You want to make sure to tell your calculator, I want to do 314.2 divided by, and then in parentheses, 25 pi. You want to keep that 25 pi as one unit. So if we do this, if we divide by 25 pi, we are going to get something pretty close to 4. I think it's going to be like 4.000 something something. I'm going to call it 4. So this is going to be 4 equals r squared, because that's all that's left over here on the right. Then I'm going to take the square root of both sides, and I will find that r equals 2. So my radius is 2 feet. And you can always double check this if you're like, ooh, this seems like a really complicated computation. Maybe I want to go back and just make sure that I've done this correctly. Plug it back in. Plug this in for r, plug 25 in for h. Make sure that your volume is what you started with. Here's one for you to try on your own. Let's say we have this new cylinder. Our radius is 5 centimeters. Our height is unknown, but our volume is 628 cubic centimeters. We want to find h, so go ahead and try to find this on your own. The one thing I'll say is for this problem, I just used 3.14 as the value of pi. So if you want to solve this, you're probably going to have good luck with using 3.14. All right, pause the video right here and give this a try on your own. Okay, you should have found that h equals 8 centimeters. I started with that formula and I worked my way down using what I knew. If you want to pause it right here and take a closer look, now would be a good time. Thank you for joining me. Go ahead and flip back to that Google Doc to make sure you know what your assignment is for today, and I will see you next time.